Hello world, Chalkers here, JavaScript developer and project lead here at thingsSDK, and I'm so excited to share with you the tools that we've been building to help you professional JavaScript developers work on projects with electronics. Now, over Halloween, I was inspired to create this pumpkin. There was some Arduino code for it, I couldn't find it, but I was able to program it really easily with JavaScript using the tools that we've created called thingsSDK CLI. Now, the way that this works is different to other JavaScript frameworks. Other JavaScript frameworks require you to use a USB and it sends commands to the microcontroller, the small computer inside here, to display images. However, with thingsSDK, you don't need a USB. This is untethered. So this has a microcontroller, which is a small computer inside that's Wi-Fi enabled, and it's super cheap, and it comes in all sorts of different sizes. The microcontroller is called the ESP8266, and it comes in a wide variety of formats, including the D1 Mini, the Adafruit Feather Huzzah, and the Node MCU. All of these development boards includes the microcontroller called the ESP8266, and it's Wi-Fi enabled. This microcontroller only costs $2. And the development boards are cheap too. This ranges between $3 to $4, so does this one. And this Adafruit one that has the charging circuitry is manufactured here in the US and costs $15. So how do we get JavaScript on these things? This is where Flash.js comes in. Plug in your device and click Flash. Flash.js is a cross-platform application that runs on Mac, Linux and Windows. It goes out and downloads the latest binaries and flashes it to your device. The binaries are for a runtime, or think of it like the Node.js of the microcontroller. We're using Espruino. Espruino is actually running on the device once it's flashed. Flashing is the process of installing these binaries or firmware to the device. Within a minute, Flash.js will have installed the runtime onto the device itself. JavaScript is actually running on these microcontrollers. Once JavaScript is on the device, what do we do next? You use the command line utility thingsSDK CLI. To install it, type npm install thingsSDK-CLI-G to install it globally. I've already installed it on my machine, and it installs the command thingsSDK. thingsSDK has several commands. The most common one you'll use is new. This will create a new thingsSDK project. Then you pass it the name of the project you want to create. So I'm going to do Hello World. Then a series of prompts will occur. You select the COM port which your device is connected to. If you're on Mac or Linux, this will look slightly different. And then you select the baud rate. The baud rate is the communication speed between your computer and the device. This is used to upload code to the device. Espruino for the ESP8266 default baud rate is 115200. If you select a 9600, you're going to be in trouble because it's communicating at a different rate and your code will not upload correctly. Hit enter and then cd into the directory. You could use npm install to install the dependencies, or you could use yarn. Once your dependencies are installed, you can open up your favorite editor, whether it be WebStorm, Vim, or Visual Studio Code. As you can see, thingsSDK has created some files for you. It's created a package.json, which contains all your development dependencies and scripts you can run, and a main.js file with a main function. thingsSDK projects only require you to implement a main function. This function is called when the board is initialized. The code generated is a Hello World application. In electronics, that's blinking an LED. On the board, there's a blue LED, and we're going to switch that off and on every half a second. To run it on the device, run npm run dev. Once it's deployed, you should be able to see there's a blinking LED. When running in dev mode, a REPL will start immediately after the code is sent. You can do things like type variables like isOn to see whether if the light is on or off. You can also do things like 1+1 and set other variables up. This JavaScript code is actually on the device itself. This isn't running on your computer. Press Ctrl+C twice to get out of the REPL, and then unplug your device. Plug the device back in, and you'll see the code isn't running anymore. That's because when you use npm run dev, it just sends the code but doesn't save it to the device. Once you're happy with the development mode, you can deploy your code permanently using npm run deploy. When you use npm run deploy, it doesn't run a REPL afterwards. You can then unplug your device and plug it back in. As you can see, it's blinking every half a second. Finally, I just want to point out devices.json. This is created when you create the project. This isn't committed to your GitHub repository, because if you're sharing a project with other people, their devices will often be different on different COM ports. If you're cloning this project from elsewhere, you can use the thingsSDK command devices. This command will create a new devices.json based on the answers to the questions. I hope you're excited as I am about thingsSDK and the suite of tools that we've created for you professional JavaScript developers to get into JavaScript and hardware. Be sure to check out our guides and GitHub repos for more information.